All right, we are going to start with the first video of Calculus 1, and we're going to start, like I said in kind of the intro video, relatively easy. So we're going to start with the simple concept of interval notation. And I'm also going to get used to writing it on the board. The concepts I'm teaching, that marker does not work very well. We're not going to use that one. All right, so interval notation. So interval notation is used when you're trying to represent a set of values really between two numbers. And interval notation typically uses parentheses or brackets. And so I'm going to put some numbers in here and just briefly describe in a little bit more detail exactly what this means. So in here we're going to put 1 and 2, in here we're going to put 3 and 4. And I'm going to draw this visually on a number line just to convey the idea a little bit more clear. So let's say we have a number line. I'm just going to put some values, 1, 2, 3, 4, 5. So this set here on the top left, this is saying, or this is representing all values between 1 and 2. But with the parentheses, we're saying that we're not going to include 1 and 2. So this is how it's written on a number line. So we'll draw a circle around 1 and a circle around 2. And then put a line between them. I know I picked two values that are relatively close, so it doesn't, it's not a very large diagram. I'll try to actually, I'll just redraw it. So new number line, 0, 1, 2, 3, 4. All right, and so we're going to do this first top left interval between 1 and 2, and we're not including 1 and 2, so we're drawing circles around 1 and a circle around 2. Now let's say we want to draw this one. With the brackets, we're saying that we're including 3 and 4 in the set. So when we draw this, we're putting a dot around 3 and a dot around 4, and we're connecting the dots. And this represents every value between 3 and 4, including 3 and 4. And so with interval notation, you can combine these two. You don't have to have only parentheses or only brackets. We could have a set that is a bracket on one side and a parentheses on the other. And here we'll do 0 and 3. So this would be representing all the values, all the numbers between 0 and 3, but we're going to include 0, but not 3. So including 0, we'll draw a dot. I'm just going to put it above it at this point. Normally you draw it on the line. We're going to put a dot at 0. We're going to draw a line over to 3 and put a circle over 3. And again, this represents every value between 0 and 3, every conceivable value. So you could have 1.5, you could have 1.33333 repeating. This is an infinite number of values between these 2 points. Now when you work with infinity, it's going to change it a little bit. So right now we have finite values, but we can represent an infinite amount of, or really, I mean this is an infinite amount of values between these two numbers, but you can put infinity on one side or both sides if you want. Whenever you add infinity though, you cannot have a closed bracket. Infinity is not necessarily a number per se. Infinity is more of a concept of never-endingness. So infinity represents just an infinite number. It just keeps going. You can never write it out. And so that's why we don't say that it's closed. It's never ending. Closed implies an ending. So let's say we want to represent the values from 1 to infinity. This is representing, again, since it's a bracket on the left-hand side, the value of 1. So we're going to put a dot. And then it's just going to keep going. So we're going to put an arrow on the right side. So that is how you represent infinity with interval notation. And this will come up a fair amount in Calculus 1. when we start getting into intervals and derivatives and diving deep into analysis of equations. But that's really all I wanted to talk about with interval notation. If it doesn't quite make sense, feel free to watch the video a couple of times, maybe even draw a couple of number lines out. Just try to plot some random intervals you generate yourself and just kind of get used to the topic. But I'm going to move on because this is relatively simple for most people, and I'm going to get into a small application of intervals and interval notation. So next we're going to actually move on to a concept of inequalities. And I want to start this concept, actually I got to remember, write it on the board. So inequalities. So I want to start this concept with just reviewing what a general equation is. So let's say you have the equation 3x equals 3. Now most people could look at this and just see, well, to get this side to equal to this side, x has to equal 1, because then you get 3 equals 3. Let's say you didn't know that. To solve this equation, on the left-hand side, you'd multiply by 1/3 or divide by 3, whichever you prefer, and then do the same to the other side. And this 3 would cancel out with this 3 because this 3 is in the numerator, this 3 is in the denominator. And same thing on this side. 3 in the numerator cancels with 3 in the denominator. And you're left with 1 and x. So you'll get x equals 1. Now with inequalities, we are replacing the equal sign. Most of these rules are going to stay the same. And I'm going to show you the exception to that here in a second. But with inequalities, you're saying that x is not necessarily going to be a value, a single value. It could be anything in a range of values. So let's say we have the same equation, 3x on the left-hand side and 1 on the right-hand side. But this time, instead of saying that they're equal, we're going to say 3x is always greater than 1. To solve this, we do the same thing we did above. So we're going to, oh, sorry, not 1. We used 3 last time, so x equals 3. Oh, shoot, sorry. So x equals 1. So we're saying 3x is greater than 3. So we'll do the same thing we did last time. We're going to move the 3 on this side over to this side by multiplying both sides by 1/3. These are going to cancel. We're going to get x is greater than 1. So again, x is not a value. You could plug in an infinite amount of values here into x and make this true, this inequality true. So if we put in 2, we would see 2 is greater than 1. 3 is also greater than 1. It's a whole family of values. And we represent this with interval notation. So with interval notation, we know it's going to be infinity on the right-hand side, because anything above 1 is going to make this true. Anything above 1 out to infinity. On the left-hand side, note we are not saying that this is ever equal to 1. We're just saying it's greater than 1. So we're going to have an open bracket on this side, and we're going to say 1. So x is going to equal this range of values. It can equal anything greater than 1 out to infinity. So you'll get a couple of these concepts and questions later on in Calculus 1, and this is really how you have to answer it. Now the caveat with this, the point or the situation where you can't follow exactly the same rules with inequalities as you did with a normal equation is when you have a negative number on one side and you have to multiply both sides by negative. So I'm going to put a new example up here. I'm going to put negative 2x is equal to 5. Oh, sorry, not equal. So we're doing inequalities. So we'll do negative 2x is less than or equal to 5. So when we do this, we're going to do the same thing that we normally do with an equation. We're going to multiply both sides by negative 1/2. But when you do this with a negative, you have to flip the sign. So this will cancel out, the 2's will cancel out, the negatives will cancel out, and you're going to get x, again flip the sign, is equal or is greater than or equal to negative 5/2. And if it's not quite obvious at first of why you flip the sign, you can consider just two numbers, not an equation, nothing involving x. You can consider two numbers and then multiply both sides by negative 1 and see what happens. So let's say you have 1 and 2, and you say normally 2 is greater than 1. Now when you multiply both sides by negative 1, you're going to get negative 1. If we didn't flip the sign, we would say that that is less than negative 2. If that was true, we'd be saying that if you were in debt $2,000 or you were in debt $1,000, it'd be saying that you have more money being $2,000 in debt, which is not true. You would have less money, and that's showing that negative 2 is less than negative 1 on the number line. So for this to still be true, you have to flip the sign. Show that negative 2 is indeed a smaller number than negative 1. All right, we are going to apply this to a bit harder of an example. We're going to use a quadratic equation this time rather than just a simple linear equation. Again, for those of you that haven't had math for a long time, feel free to pause the video, maybe go back, try a couple examples of these yourself. I'm not going to make these videos really long, so I'm not going to really belabor any of these concepts longer than I have to. Again, if you have any questions, please put them in the comments. I'll look at them. I'm, again, not expecting too many views. If I do get a lot of views and comments, then I probably won't be able to answer everything, but if you do have questions, I'd be happy to help out. But we're going to start with, or I guess continue with, a quadratic equation inequality this time. So I'm going to choose, actually I'll use black here for this. I used green last time. So I'm going to choose this quadratic equation, x squared minus 4x minus 5, and we're going to say it is less than 0. So I already know what this equation is going to look like, so I'm going to graph it for you beforehand just to give you an idea of where we're headed with this. So if we graph this equation, and when we graph it, we're actually graphing y equals x squared minus 4x minus 5. So when we graph this equation, we plug in all sorts of values for x, we plot the values for y, and we get a curve. The curve will look something like this. And so what we're saying with this inequality up here is we're saying we want to know the interval in which the value of y, again because y equals this, the value of y is less than 0. So we're looking for the interval here that falls in this space, because all of this space here is below the x-axis, so it's where y equals a value less than 0, something in the negatives. So that's the goal. We want to find this interval here, this interval of x values. And to do this, I'm going to start out by factoring this equation into two things multiplied together. So this is a concept. I know there's a lot of other videos on YouTube that really describes this concept, so I'm not going to go in too much depth here, but this quadratic formula can be split using a reverse FOIL method into two pieces multiplied together. And so it's going to be x minus 5 on one side plus 1 on the other side. And if we multiply this out, we would realize that we get this quadratic formula. So when we're trying to find the inequality, we can first find when this actually equals 0. Because as we saw with the graph, it's going to equal 0 twice with a quadratic equation, with this particular quadratic equation, because we saw that it went below the x-axis and then came back up. And an easy way to see when this is equal to 0 is when one of these is equal to 0, because anything multiplied by 0 is going to be 0. If you have 5 times 0, it's going to be 0. Like pi times 0, e times 0, e to the pi times 0. So to get this to equal 0, just one side has to equal 0. And that occurs when x equals 5 or x equals -1. If x equals 5, on this side you're going to get 5 minus 5, which is 0. If that's x equals -1, you're going to get -1 plus 1 equals 0. So x is going to equal 5 or -1 for y to equal 0. So we know that these are going to be the two boundaries of that interval that we're looking for. So we know it's going to be -1 to 5. But we don't know, at first we don't know exactly if it's going to be a bracket or if it's going to be a parentheses or a bracket. And we can check this when we look at the symbol here. Notice we didn't use less than or equal to, we just used less than. So in this case, it's actually going to be just two parentheses, because we're not interested in the range when it equals -1 or equals 5, only when it's less than 0. So this is really going to be the answer. And we can check this as well if we look at values outside this range or inside this range to see if it's negative or positive. So to double check, I'll choose -2, and I'm going to plug it into this equation and just see if the result is less than 0 or greater than 0, just to double check that we have the right interval. So plugging in -2, we're going to say when x equals -2, x squared is -2 squared, so that's going to be 4, minus 4 times x. Again, x is -2, so it'd be really plus -4 times -2. The negatives cancel out and you get 8. So it's actually going to be 4 plus 8, and then we have minus 5. 4 plus 8 minus 5 is going to be 7. Right, yeah, 7. 7's positive, so that would not fall under this, this rule. 7 is obviously greater than 0, not less than. So we know that at least on the left-hand side, this is correct. We should not be including anything less than -1. Now let's choose a number in between this interval, between -1 and 5. Just for simplicity, we'll choose 0. So when x equals 0, x squared will equal 0. So we're going to get 0 plus -4 times 0 is going to be 0, and then minus 5. So we're going to get minus 5, and this is indeed less than 0. So this checks out. And now let's choose something outside of this interval on the right-hand side. So we'll choose 10 in this case. X equals 10. When we plug this in, we're going to get 100 minus 4 times 10 minus 5. And this is going to equal 55. And 55 is not less than 0. So we know on the right-hand side as well, outside of this interval, this is not true. So this interval here must be the correct answer. This is all the values of x that will make this inequality true. So I would encourage you to practice this a little bit. Not a whole lot, maybe just choose like 1 or 2 problems to just practice some quadratic formulas. If this was a little bit hard, if not, feel free to move on. I know some of you this may come back faster than others. But alright, so we're going to move on from inequalities, and we're going to talk about what do I have? Absolute values. So this will actually be the last topic for this this video today. So absolute values. So what an absolute value is, it's a notation with 2 vertical lines with something in the center of it. And really what the absolute value does is it takes away the negative if it's there. If it's positive, it doesn't do anything. So if we had 2 in here, the absolute value of 2 is just 2. If we had -2, it's still just 2. It takes away the negative. If we had negative pi, the absolute value of negative pi is just pi. Relatively simple, don't overthink it. And what this is actually representing, it might be kind of a weird notation that you're wondering why it's used, why it's useful. The absolute value is just trying to figure out how far away from 0 the number lies. So if we have a number line, 0, 1, 2, 3, on this side, negative 1, negative 2, and negative 3. The absolute value is saying just how far away from 0 are we at. So we have negative 3, and we take the absolute value of negative 3. We're just saying it's 3 units away from 0. And you can think of this in terms of going on a run from your house. Whether or not you go north or south, if we say that south is negative and north is positive, no matter which direction you go, whether it's negative or positive, you're still running an actual distance. You're still expending energy to get away from your starting point, from 0. It's just looking at how far away did we move from 0. So absolute values do have some rules. It's relatively simple when you just have a number with a negative. But when you start introducing this into equations, you're going to have to follow a couple relatively simple rules. When you think about it in depth, they become a little bit obvious. I'm going to try to show that and communicate that here with this video with a few examples. The first rule of absolute values is saying when you have an absolute value of a number divided by an absolute value of another number, that's going to equal the absolute value of the entire fraction. If we plug a couple numbers in here, we'll see that this is relatively obvious. So let's say a is equal to negative 1 and b is equal to positive 2. So let's plug these into this, this equation on the left-hand side, and we're going to see that the absolute value of negative 1, we're just going to take away the negative. That's going to equal 1 over absolute value of 2 is just 2. So that's the left-hand side. If we, here, I'll divide these. These are two separate things. So if we plug in numbers to the right-hand side, we're going to see it's the same thing. I'm running out of room. So a over b, we have the absolute value of negative 1/2. So negative 1/2, and that's just going to equal 1/2 again, because even though it's a fraction, we're still taking away the negative. So this general rule still holds. Absolute value of one number over the absolute value of another number is the same thing as the absolute value of the entire fraction. All right, so the next rule is going to be with powers. So let's say, we'll keep the same numbers. So a equals negative 1, b equals 2. So let's consider this time a raised to the power of b. So a raised to the power of b is going to equal negative 1 raised to the power of 2. So this normally equals negative 1 times negative 1. The negatives cancel out and you just get 1. Now let's throw an absolute value in here. Let's say instead of this, we're going to do the absolute value of negative 1 raised to 2. This is going to equal the same thing. We're going to get negative 1. Well, we're going to start out taking the absolute value of negative 1. This is going to equal 1 raised to the power of 2, which is just 1. So it's 1 times 1. No, I'm not going to erase that yet. So now consider the absolute value of the entire thing. So negative 1 raised to the power of 2. This is also going to be true because we take the power first. So we're going to do negative 1 to the power of 2 like we did up here. And it's just going to equal the absolute value of 1, which equals 1. And we used an even exponent, so the negatives are always going to cancel each other out. But this is also the case with an odd exponent. So let's say negative 1 raised to the power of 3 this time. Since cubing something is multiplying the same thing 3 times, you're going to be left over with a negative here. So let's say you have this absolute value of negative 1 to the third. This is going to equal absolute value of negative 1 times negative 1 times negative 1 equals the absolute value of negative 1, which equals the absolute value of 1. Oh, sorry, not the absolute value of 1. It's just going to equal 1 because the absolute value will take away the negatives. So this is the general rule here to sum all of this up. The absolute value a raised to the power of b is equal to the absolute value of a raised to the power of b. So you can move the absolute values in and out of the exponent, and it's still going to be true. I hope that wasn't too confusing. I got a little tripped up there for a second. But we're going to keep moving on. This is all a learning experience. So the last thing I'm going to talk about here is the triangle inequality. The triangle inequality pops up once in a while here in physics and mathematics. It's used relatively often. We're not going to give any examples because I want to keep this video relatively short, but we're going to talk about it a little bit. So this is going to be the triangle inequality. So the triangle inequality says if you have the absolute value of a plus b, this is always going to be less than or equal to the absolute value of a by itself plus the absolute value of b by itself. And if this isn't immediately obvious, we can just plug in a couple examples and we'll see that this always works out. So let's plug in a positive value for both a and b first and just see what that happens. Or see what happens with that. So let's say a equals 2, b equals 5. So plugging in 2 and 5, we get the absolute value of 2 plus 5. It's less than or equal to absolute value of 2 plus absolute value of 5. On the left-hand side, we're going to get the absolute value of 7. On the right-hand side, we're going to get 2 plus 5, which equals 7. And we get 7 less than or equal to 7. And this is true because one of the options is equal to. So 7 is indeed less than or equal to 7. Now I'm going to try it with two negative numbers this time. So a equals negative 3, b equals negative 4. So plugging it in the same as before. On the left-hand side, you have absolute value of negative 3 plus negative 4. It's less than or equal to absolute value of negative 3 plus absolute value of negative 4. I ran out of room. On the left-hand side, with the absolute value, we're going to start by adding these two within the absolute value notation. So we're going to get negative 3 plus negative 4 is negative 7. And we're going to say that is less than or equal to, and here, since we don't just have one number in it, the absolute value is going to take away the negative. And we're going to get 3 plus, same thing on this side, 4. And now on the left-hand side, we just have one number with a negative, so we're going to take that negative away. And this is going to equal 7. It's less than or equal to, add these together, and get 7 again. So 7 is equal to 7. And the final example, I'm going to choose one negative and one positive. And then that will cover really all the bases we could possibly choose with this equality. We're going to say a equals negative 1, b equals 10. So again, one negative value and one positive value. And we're going to plug these into this equation. On the left-hand side, we'll get absolute value of negative 1 plus 10 is less than or equal to absolute value of negative 1 plus the absolute value of 10. So on the left-hand side, we'll make the addition here inside the absolute value first, like we always have. And this is going to equal the absolute value of absolute value of positive 9 is less than or equal to 1 plus 10. And so we're going to get 9 is less than or equal to 11. And that is true because 11 is bigger than 9.